Alright, if K is equal to the slope, how do you find the slope? Rise over run. It's changing y over the change in x. Or you can say y2 minus y1 over x2 minus x1. Pick two ordered pairs. The ones that I picked because it made it nice and easy. Get some that are on the graph exactly, that fall straight on there. So I would do 0, 0. And I'm going to do whatever that is. What's that going to be? 3,200? No, that's 3,200. So it's going to be 2,800. And minus 3. Y'all see? And that's what I would use.
What? 2,800?
I'd use the x as 20. Let's see. What's the increments here? What is the increments here?
What's the increment?
800? 400? Alright, so this is going to be 2,800 and negative 3.00. So that's going to be what I would use. So I could say for my y2 minus y1, I could do 0 minus a minus 3 divided by 0 minus 2,800. That's going to be a crazy slope. Alright, so when I punch that in, that could give me K. And well, the slope is going to be negative, but remember K is going to be positive. Are we good there? Yes, no? And again, I'm not going to work it out all the way. I'm going to get some pieces parts of it. Okay.
Is that it on there?
Huh?
Is that it on this page?
Just about. Alright, now, on the
Wait,
V.
why do you have void by the element?
Okay, down here on, this is for IB, okay? Now, if I'm trying to determine the concentration of H2O2 after 2 minutes have elapsed, that means I'm trying to find the concentration of H2O2. I know my time is equal to 2,000 minutes. I know K because I found it up here, okay?
Oh,
And
that's
then
the original.
the H2O2 original, if I look at my original graph, okay, at time equals 0, the H2O2 is 1, okay? So I'm going to call it 1. Yeah, Aaron?
For binary K, can you just count from the 0 to the bottom where it runs over the 2,800 and then just divide?
Okay, I'm doing what now? Probably. You always find a different way to do it that seems to work well.
That's what I do.
You what you counted over?
Yeah, I went down and over and then
Divided by what?
it was like,
The one on the bottom.
it's 3 divided by 8.
3 divided.
Oh, okay, okay, yeah, I see, because it was 0 already, yeah, that's fine. I'm with you now. And you'll get the same answer. Okay, yeah, Philip?
What problem is this?
This is 2004B.
Like, which one are we just doing?
It was, IV on 2004B. It's the very last one on it. Alright. Are y'all with me? Is that okay? We can get that now? Alright. Now, I want to talk you through a little bit on 2005B because a couple of these are hard. And most of you just turned to that page, saw the charts and graphs and went, too hard. Which is what you do on ACT.
No. Yeah.
Okay.
ACT, I make 28.
Okay.
I'm at a 28.
Ever got
Yeah, I'm not even gonna tell you all my scores on my last day.
What did you get? 28?
yeah, in science.
What'd you make altogether?
Okay.
25.
Yes, guys.
My reading for 21.
Can I say that last
Okay,
one?
not
Can I say what you just showed in the IV?
No, not everything, but.
Here's my opinion.
Okay, now, first of all, guys, let's look at this. Before I even look at the questions, they give me 3 graphs. They give me a graph of the concentration versus time, the natural log versus time, and the concentration to the -1, which is 1 over the concentration versus time. So what order is this one? First order. So you can get that real easy from the graph. Okay, so I know this is first order just from the graph. Now, I want to know how many moles were initially in the flask. You can look at the graph, or you can just look way up here at the beginning of the problem. Initially, it's going to be time equals 0, isn't it? So at time equals 0, I'm going to have 0.00633. So I'm going to have 0.00633 molarity. Okay? But it asks how many moles of X. So let's look back up in the problem where I have to read all this mess that they said, because that's probably important. Alright. In a certain experiment, the reaction took place in a 5-liter flask at 428 Kelvin, and it gives you all the graphs. So how am I going to find the moles? Right. Moles is just molarity times liters. So really, molarity is moles over liters, and then times 5 liters is going to give you moles. Okay? And so that's going to give me my moles of X. Are y'all with me there?
Yeah.
Alright. What if I'm trying to find how many moles? I'm going to rewrite the equation down here. It would be nice to have it, so I didn't have to flip back and forth. What if I wanted to know how many molecules of Y were produced in the first 20 minutes of the reaction? What kind of problem do you think this is going to be? Stoichiometry. Alright, so I've got to look back up at my graph. My goodness, that channel. Alright, I've got to look back up at the graph at 20 minutes. Okay, so I can look at the data table. I'm going to look at the data table at 20 minutes. This is the molarity. So if I know the molarity of X is 0.00427, I've got to get to moles of X, and then I've got to get to moles of Y, and then I've got to get to molecules. And I'm writing all this, and you can't see a thing I'm saying. Okay? So I've got to change that concentration to moles, then do a mole ratio, then do the 6.022.
Wouldn't you take the moles that you have at 20 minutes and then subtract it from what you had at the beginning?
Oh, right. Yes. You got to know what reacted. Yes, I do. Thank you. All right. That should be the 0.00633. I almost made a big goof, didn't I? 0.00427, because you won't have any reacted.
Yeah.
That's right. Thank you. That would tell you how many remain.
So you would,
Because it's wanting to know how much was produced in the first 20 minutes, so you gotta know how much reacted. You gotta know how much went away. Alright. Now, tell me on C, what did we say the order of this reaction was? How can you justify that? Alright, because the graph of the natural log versus time gives you a straight line. Now, let me tell you on that one, y'all listen, so that you don't mess up on the test or on free response. The thing that kills people on kinetics is it's easy questions, you know the answer, but you don't say it right. If you're justifying your answer on C, you can't just say because of the graph. Okay? You've got to say because the natural log of X versus time gives you a straight line. Okay? You've got to explain it. You can't just say because of the graph. Yes. I would say, well, you've got 3 graphs there. I would go ahead and say the natural, you need to say the graph of the natural log versus time. You want to make sure you're covering your bases on that. So I'd go ahead and say everything.
The first one just graph is a straight line with all the first order.
Well, but say the graph of the natural log versus time
Yep.
is a straight line.
So I got a video picked up.
They get crazy on stuff. All right. So we can handle this now. E, how are you going to find the rate constant? slope. Alright, and then S, if I'm trying to find a concentration after amount of time, what's that gonna be? That's gonna be your integrated rate law. Alright, can y'all handle this? And again, I'm just trying to give you some hints on these.
These general,
Yeah, yeah.
you said there's.
Is that all?
You just.
Alright. So what?